Hey guys, we're at the last section of Chapter 5, Section 8 here, where we're going to be talking about graphing absolute value functions. It says an absolute value function has a V-shaped graph that opens up or down. The parent function for the family of absolute value functions is y equals the absolute value of x. The graph of this, in general, the parent function, this graph right here, looks like this. All right, so this V part is what we're going to be kind of focusing on today. That's kind of the most basic absolute value function graph that there is. A translation is a shift of a graph horizontally, vertically, or both. The result is a graph of the same size and shape, but in a different position. In other words, you're just sliding it around or you're moving it somewhere. All right, so here's a true story. When a girl messes up a guy's hair, he thinks it's so cute. But when a guy messes up a girl's hair, may his soul rest in peace. True story. True story. Yes, yes. All right, describing translations. Below are the graphs of y equals absolute value of x and y equals the absolute value of x minus 2. How are the graphs related? Well, you'll notice here that this is the parent function, like I was saying before. Y equals absolute value of x looks like this. And then minus 2 shifts it down 2. Notice that the minus 2 is on the outside of the absolute value sign. This is a y-intercept. We've talked about these constants before. So this constant right here tells you where it crosses the y-axis, which is right here, negative 2. So this shifts it down 2 places. So how would we say, how is the graph related to the graph of y equals absolute value of x? We'd say the graph moves up. Let's see, 1, 2, 3, 4 units. All right, so the graph moves up 4 units would be the description of that translation. That's good enough for me. That makes sense. All right, so here's how you graph a vertical translation. It says the graph of y equals absolute value plus k is a translation of y equals the absolute value of x. Let k be a positive number, then this plus k translates the graph of this up by k units. If it's minus, it transfers it down k number of units. That's all that's saying. So if it's on the outside of the absolute value sign and it's positive, that tells you how far it goes up. If it's negative, that tells you how far it goes down. So what is the graph of y equals the absolute value of 2? Well, we know that the parent function, let me change my color here. We know that the parent function looks something like this, and you'll have to excuse my lines that are not very straight. Notice how that on the parent function, it's going through where this grid crosses every time. If you think about what this looks like for a XY chart, if I put in just a couple values, negative 2, negative 1, 0, 1, and 2 very quickly. Well, the absolute value of negative 2 is 2. The absolute value of negative 1 is 1. 0, 0. 1 is 1. 2 is 2. And so on. So this mirrors just y equals x, except it's going up the other direction. All right, so whatever the x value is, it's the positive version of that. To do this plus 2, I just add 2 to all of these different values. So this moves everything up by 2 places so that the new graph would look like this. All right, so this is the graph of the absolute value of x plus 2 right here. This is the parent one right there. Here's one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. There it is. Hopefully you got something like this. Let's keep moving here. All right, it says the graphs below show what happens when you graph x, the absolute value of x plus 2 and x minus 2. Notice that these are in the absolute value sign. For a positive number h, y equals plus h translates the graph left h number of units. So plus h moves it to the left. Minus h translates the graph to the right. This is kind of the opposite of what you would think intuitively. You'd think, well, it's plus, I'm going to move to the right. If it's minus, I'm going to move to the left. You're actually doing the opposite on this one. It's important to have this down in your notes and have it down correctly. So plus 2 just moves this over 2. So 1, 2, there it is. And then this one would be minus 2, so it moves it over this direction, and that's our new graph. So that's how we get a horizontal translation with an absolute value function. Okay, so what is the graph of x plus 5? It's a plus 5, which means I move it to the left. So I have 1, 2, 3, 4, 5. There's my spot, and then I graph the absolute value function. And it looks something like that. So this is pretty straightforward. Here's one for you to try. The answer will be up in 3, 2, 1. There you go. So hopefully you saw that this one moves to the right. And let's keep moving along here. Okay, the absolute value function is an example of a piecewise function. A piecewise function is a function that has different rules for different parts of its domain. For example, when x is greater than or equal to 0, then the absolute value of x is just the line x. And this is what I was talking about earlier. When it's less than 0, it's actually negative x. It's the one that comes down like that, diagonally. Another example of a piecewise function is called a step function. Step function is a function that pairs every number in an interval with a single value. The graph of a step can look like the steps of a staircase. So here's an example of what a step function looks like. This may look kind of weird, but there are some really practical applications of this that we're going to take a look at here. Okay, so here it says a school will charter buses so that the student body can attend a football game. Each bus holds a maximum of 60 students. Make a graph that models the relationship between the number of students x that go to the game by buses and the number of buses y that are needed. Okay, so the first thing, let me change my marker color back to yellow. Y is my number of buses, and x is the students going. Now let's go ahead and get some intervals on here. So we'll call this point 0, and we'll just say 1 bus, 2 buses, 3, 4, and I don't know. We may get to 5. All right, number of students. It says each bus holds 60 students, so it makes sense to just increase this by 60. So 60, 120, 180, and let's do one more. 240, 300. Okay. So here are our intervals, the number of buses, and then the number of students going right here. The next thing that we need to think about is, well, how is this going to look? If there are 0 students going to the game, then that means we need 0 buses. So 0 students and 0 buses would create a spot like this. Now, if 1 student decides to go to the game, okay, or let's think of it this way. If 60 students decide to go to the game, then we will need 1 bus. So I need this point right here. And this point goes all the way back to if 1 student wants to go. So the way that you draw this up is this is already taken. So I need an open circle right there, and I fill in this. What this line means is that any number of students from 1 to 60, I only need 1 bus. But the moment I get that 61st student, the moment I get 61, I have to go up to 2 buses. And I'll have 2 buses all the way to 120. So if I have 120 students, I need 2 buses. If I have 61 students, I need 2 buses. But if I have 60, I only need 1. All right, so this is how a step function is going to look. For students 1 through 60, I get 1 bus. 61 through 120, I need 2 buses. I go up to 3 buses for 180. And this is how the step function works. Hopefully that makes sense to you. So here for 4 buses, I would need that. For 300 students, I would need 5 buses. And the reason this is called a step function is it looks like a staircase. All right, but it tells a very, very important story. This is what a step function looks like, and that's what it means. And I think this hopefully makes sense to you in terms of its usefulness. So here's one for you to try. Go ahead and pause, or I'll pause. The answer will be up in 3, 2, 1. All right, here is my graph. Notice this looks very similar to the one that I did in the example before, except I'm increasing by 50 students every time. So hopefully you got something that looks like that. Step functions in general they generally almost always look exactly like this. Okay, the intervals may change and that kind of stuff's fine, but this is generally how they're going to look. The more important thing to me is that you understand what it tells you. So hopefully that makes sense. That's it for today. I'll see you in class.